Next we will see the nomenclature of alicyclic compounds. What is meant by alicyclic compounds? Alicyclic compounds and its classification we already studied. The compounds which resembles aliphatic compounds, isn't it? In their structure and properties. So first we will see, before we start the naming of alicyclic compounds, we have to revise. Which are the alicyclic compounds we studied? Yes, one is cyclopropane, then cyclobutane, cyclopentane, cyclohexane, etc. Now we will see few rules which we have to see when we do the naming of alicyclic compounds in addition to the previous rules. So again, the previous rules are also applicable here when we do the naming and all. Here the main differences. Now we are going to do the naming of an alicyclic compound. They are ring compounds actually. So here you will definitely you can see one ring. Sometimes along with the ring you can see some branches or chains. So here we are going to do the naming of ring compounds, alicyclic compounds. So we will see what are the rules. What are the additional points that we have to see? The first one is the name of the alicyclic compounds. We know cyclopentane, cyclobutane, cyclohexane. What is the main difference actually in the case of alicyclic compounds? How we are getting the name of the compound or the parent ring? It is by adding the prefix, that is cyclo, to the name of the hydrocarbon. Cyclopentane, pentane is the hydrocarbon, that is the parent. We are adding cyclo to represent the cyclic or ring structure. Now, in a ring structure, when we get a compound containing alicyclic ring, okay, in that ring, if two or more alkyl groups or substituents, because alkyl groups are always considered as substituents, isn't it, as prefixes only. So if we get a ring compound or alicyclic compound containing two or more alkyl groups or substituents, then the ring we have to do, how we are doing the naming of an aliphatic or a chain compound, we are giving number to the carbon atoms present in the parent chain. So here we have to give the number in the ring. So and the positions are indicated by the numerals 1, 2, 3, etc. For example, we will see the naming of an alicyclic ring containing alkyl groups. So see the first compound, yes, it is a cyclopentane ring, that is a 5-membered ring containing 2 methyl groups as substituents or branches, isn't it? So when we here instead of chain we have to give number in the ring. So when we give number just like the chain, when we give the number in a ring, carbon atoms, the carbon atoms present in the ring, here also the branches or the substituents or the functional groups should get the lowest possible number. So when we do the naming, when we do the numbering in a ring, it's not like a chain compound. Chain we can do numbering either from left to right or right to left or top to bottom or bottom to top. So here either in the clockwise direction or in the anti-clockwise direction. So remember in the ring compounds how we are doing naming, either in the clockwise direction or in the anti-clockwise. Okay, only in one direction we can do the numbering. So here they have to get the lowest possible number. So either we can do clockwise 1, then it should get number 2. Then 3 will be here 4. So 4, 5. Actually 3, 4, 5 no need to represent because there is no other substituents present there, because we know the ring structure, it is cyclopentane, isn't it? So how we can write the name as, it is a 5 carbon containing ring, so it is pent. They are singly bonded, so the primary suffix will be ane. Now alicyclic compound structure, how we are getting by adding the prefix, that is cyclo, so it is cyclopentane. Isn't it? No need to write like this. From the structure it is very clear because we have already studied that it is a cyclopentane ring. On first and second carbon we have in first and second position of the ring we have 2 methyl groups. So how should we write it as 1, 2 dimethyl cyclopentane. Okay, so what is the name of the compound? 1,2 dimethyl cyclopentane. or if you want you can do numbering from here, starting from here. For this methyl group you can mark it as 1 and 2, 3, 4, 5. Anti-clockwise direction also you can go. So either in clockwise or in anti-clockwise, but you will be getting same number. Now in the second compound, which ring we have as the parent? Cyclohexane. Now how we can do the naming? If we are doing in clockwise direction, don't start from here. If you are starting from here, 1, 2, 3, 4, 5, 6. Isn't it? So lowest possible how we can get, start from here, 1, 2, 3, 4, 5, 6. 6 carbon means it is a cyclohexane ring. So the parent is cyclohexane. Okay. Now on first and second carbon we have, on first carbon we have ethyl and the second carbon we have methyl. So you follow the same rule, which one should be right first, the one which comes first according to the alphabetical order. So H we have to write first, so it is 1 ethyl, 2 methyl, cyclohexane. What is the name of the compound? 1 ethyl, 2 methyl, cyclohexane. So this is about the first point that we have to see. If there is any, when we do the numbering of an alicyclic ring, we have to give number either in the clockwise direction or in the anti-clockwise direction. Now if the ring contains, so here we have seen a ring with alkyl groups as branches. So if a ring contains more or equal number of carbon atoms as that of the alkyl group or than the alkyl group. So if there is an alkyl group and attached to ring, and if the ring contains more number of carbon atoms than the ring or equal number of carbon atoms than the ring, it will be, the compound will be named as the derivative of cycloalkane. It will be named as the derivative of cycloalkane, means cycloalkane will be considered as the parent. Okay. So if the ring contains equal or more number of carbon atoms than the alkyl group present or the branch present, the compound will be named as the derivative of the cycloalkane, or the the cycloalkane will be considered as the parent. So see the example. Here in this compound given, we can see a ring with branch. So here on the ring, how many carbon atoms are present? 1, 2, 3, 4, 5 carbon atoms are present. In the side chain also 1, 2, 3, 4, 5 carbon atoms are present. So the ring has same number of carbon atoms as the side chain. So here we can consider the cycloalkane as the parent. So this will go as substituent and this will come as the parent. So this will be as number, we can start numbering from here, 1, 2, 3, 4, 5. Okay, so on first position, so the parent is cyclopentane, isn't it? In cyclopentane will be the parent and this will go as a substituent or prefix. So on first carbon we have what? 1, 2, 3, 4, 5. 5 means it is a pentyl group. So 1 pentyl. Okay, when pentane comes as a branch, it will become pentyl alkyl group. So what is the name of the compound? It is 1-pentyl cyclopentane. Now in the second example, if you look at the second example, here also a ring containing a branch or alkyl group. We have to see the number of carbon atoms in both. In the branch or in the alkyl group we have 1, 2, 3, 4, 5 carbon atoms, but in the ring we have 1, 2, 3, 4 carbon atoms. So here the cycloalkane ring is having less number of carbon atoms than that of the alkyl group. So here can we consider the ring as the parent? No. So here the alkyl group will go as the parent and this will be treated as substituent. So only when the cycloalkane ring is considered as the parent, when it has more or equal number of carbon atoms as that of the side chain. Okay. So here this will go, the alkyl group will go as the parent, this will go as substituent. So we have to take, this is the parent, so we have to number 1, 2, 3, 4, 5. Here no need to give number in the ring because that is not the parent. So 5 carbon means it is pent, they are singly bonded, so AN means, so pentane. Pentane, on third carbon we have 1, 1, 2, 3, 4. For which ring is that? Cyclobutane. So cyclobutane, when it comes as a parent only we can say that it is cyclobutane. When it comes as a substituent it will become cyclobutyl group. What it is? Cyclobutyl group. So on third carbon we have cyclobutyl group. So what is the name of the compound? 3-cyclobutyl pentane. Why? Because the ring has less number of carbon atoms as that of the alkyl group. Now, the next point is if the side chain, there is a ring as well as a side chain, and the side chain contains a multiple bond, double bond or triple bond, or a functional group. If the side chain contains double bond, triple bond or a functional group, then here also the ring will be considered as a substituent and the chain will be considered as the parent chain. Okay. So here we have a ring structure, that is cyclopropane ring and a side chain, but the side chain is having double bond. So can we consider the ring as the parent? No. So we can consider only this as the parent. So see this is our parent chain. We have a double bond and a cyclopropyl group. What is it? Cyclopropyl group. Which one should get the lowest, highest priority? Yes, one double bond is present. So 1, 2, 3. 3 carbon means it is prop, then it is prop 1-ene, and on third carbon there is a cyclopropyl group. So what is the name of the compound? It is 3-cyclopropyl prop 1-ene or cyclopropene. See the next compound, here also we have a ring with 6 carbon atoms, side chain with 1, 2, 3, 4. The ring does not contain any functional group. The functional groups are present in the side chain. So side chain will be considered as the parent. The ring will go as a substituent. Which ring is this? Cyclohexane. When cyclohexane goes as a substituent, it will become cyclohexyl. Now how should we number it? Double bond is present, cyclohexyl ring is present, that is only a substituent, least priority. So here which is the principal functional group? Highest priority functional group, C double bond O. So that should get the lowest possible. So 1, 2, 3, 4. So how should we write it as? 4 means but, 3-ene, 2-on. And on fourth carbon there is a cyclohexyl group. So the name of the compound is 4-cyclohexyl but 3-ene 2-on. Now the next rule is if a multiple bond or a substituent. Now in the previous example the functional group or the multiple bond was present in the side chain, not in the ring. Now in the second case, if a multiple bond or a substituent are present in the ring, then the numbering should be done in the ring in such a way that the multiple bond gets the lowest possible number, because we know when we see the priority, substituents are having least priority and double bonds and triple bonds are having highest priority, isn't it? So here we have a rings with a double bond and 2 substituents. So how should we number? The double bonded carbon should get the lowest possible. So either we can go in the clockwise direction or anti-clockwise. So here how should we go to get the lowest possible number? Start from here. 2, 3, 4, 5. So what is it actually? The parent is cyclopent. There is a double bond between 1 and 2 carbons. So cyclopent 1-ene. There is no functional group present. So there is no secondary suffix. On second and third carbon there is second and third position. We have 2 methyl groups. So it is 2,3-dimethyl. So the compound name is 2,3-dimethyl cyclopent 1-ene or cyclopentene. Similarly, in the next one also we have a double bond and a nitro group present. We know that nitro group is always considered as a substituent with least priority. So double bonded carbon should get the lowest possible number. So we can go only in the anti-clockwise direction. 1, 2, 3, 4. When we do the numbering in the ring system, from any position we can start numbering, and in any direction we can move. Any direction means either clockwise or anti-clockwise, but we have to select from where should we start and in which direction we have to go depending on the lowest possible number. So here the ring is cyclohex. Cyclohex, there is a double bond at 1 and 2, so 1-ene. On third carbon there is a nitro group, it will go as prefix. So it is 3-nitro cyclohex 1-ene. Now the next rule is, if the ring contains a double bond and the side chain contains a functional group. Okay, so the double bond or multiple bonds are present in the ring and functional groups are present in the side chain, then the ring is treated as, if the functional group is present in the chain, then the ring will be always treated as a substituent with least priority. So here there is a double bond in the ring, but the functional group is present in the chain. So chain should be considered as the parent. So give number in the ring. So 1, 2, 3. OH attached carbon should get the least priority because this we can consider only as a substituent. Okay. Now this is a substituent, okay, but in that substituent there is a double bond, isn't it? So we have to specify the position of that double bond also. So how should we? So here we have to do the numbering in the parent chain as well as in the ring. So here the rule already we have studied. When there is a branch or functional group or anything in the branch again, the carbon which is attached to the parent chain should be considered as number 1, 2, 3, 4, 5. So how should we number it as? How should we name it as 3? This is our parent chain. Parent chain containing 3 carbon means prop. They are singly bonded, so propan 1-ol. Now on second carbon there is a substituent, so that we have to represent only as a prefix. So on second carbon, branch with branch or branch containing again the multiple or triple or functional group, then we have to write always inside a bracket. On second carbon what we have? Yes, a cyclopentane ring containing a double bond at the third carbon. Between third and 4 means it is 3-ene. So how we can name it as? On second carbon of the parent chain we have a cyclohex 3-enyl. So here remember the parent is the chain with 3 carbons, so prop singly bonded, and on first carbon OH, so propan 1-ol. On second carbon there is a substituent present and the substituent has another double bond. So since we have to give a position to the double bond, we have to number in the substituent also. So the carbon which is attached to the parent should be always numbered as 1. So 1, 2, 3, either clockwise or anti-clockwise. But this should be always number 1. So on second carbon we have a cyclohexenyl. Cyclohexene actually. the position of double bond is 3-ene. Since it is an alkyl group or substituent, cyclohexenyl alkyl group. Okay. Now, the next rule is if the ring as well as the side chain contains functional groups. Okay, so if ring as well as the same chain both contains functional group, the compound is named as the derivative of the one which contains the principal functional group. What is principal functional group? Yes, where is the functional group with highest priority? That will be considered as the parent. Okay. So, if the ring as well as the chain contains functional group, the one which has the principal functional group or highest priority functional group will be considered as the parent. So, here we have a ring system which contains nitro group, chain with COH. So, here which is the highest priority functional group? Carboxylic acid. So, we can consider only the chain as the parent, the ring will go as the substituent. So, how should we number it? 1, 2, 3. So, here also like the previous question, on third carbon we have a cyclohexyl ring containing double bond and nitro group. So, we have to specify the position of double bond and nitro group. So, give number to the ring also. So, the carbon attached to the parent should be numbered as 1. Then, either we can move in a clockwise or anti-clockwise, that is up to us. But here according to, here in which direction we have to go to get the lowest possible? Yes, 2 should be written here, 3, 4. So, parent chain is the 3 carbon, so it is prop. Then between 2 and 3 there is a double bond, so 2-ene, 1 oic acid. Oic acid is written by replacing last E from ENE. Now on the third carbon of the parent chain, what we have is cyclohex. Okay, one cyclohex ring, cyclohex 1-ene, cyclohex 1-ene, 3 cyclohex 1-ene. Sorry, we have to write 4 nitro first, isn't it? So, nitro will go as prefix. So, 4 nitro cyclohex 1-enyl group. So, what is the name of the compound? 3. At the third carbon of the parent chain, we have a 4 nitro cyclohex 1-enyl group. Now, if a compound contains an alicyclic ring which is directly attached to the benzene ring, then benzene ring will be always considered as the parent. Okay, benzene ring will be considered as the parent, or the compound will be named only as the derivative of benzene. So, here what we can say, the name of the compound as benzene is the parent, so that we have to write at the last, isn't it? So, which ring is present here? Cyclohexane. When cyclohexane goes as a branch or substituent, it is cyclohexyl. So, what is the name of the compound? Cyclohexyl benzene. And in the last rule, that is, if a carbon atom, if a carbon containing, if a carbon containing functional group is directly attached to an alicyclic ring or cycloalkane, how should we name it as? So, here a CHO group is attached to benzene ring. So, So how we are naming is, first we have to write the complete name of the ring. Which ring is present here? Cyclohexane. So it will be named as cyclohexane carbaldehyde. These are few exceptions we have to remember. It will be named as cyclohexane carbaldehyde. So here CN group, it is a carbon containing functional group directly attached to alicyclic ring. So it will be named as, which ring is present here? Here also cyclohexane nitride. So write the complete name of the ring followed by the functional group name. So this is about the naming of alicyclic compounds. Next we will see few examples. The first one, a ring with OH and CH3 group. So here ring, only the alkyl group is having only one carbon. So ring we can consider as a parent. So from where should we start numbering? OH attached carbon should get the lowest possible. So only if we go in the clockwise direction, CH3 attached carbon will get the lowest possible number. So how the name of the compound will be? It is 3-methyl cyclohexane 1-ol or cyclohexanol. So here also in the cyclohexane ring we have one keto group and OH group. This is actually keto group, C double bond O group. C is not represented because bond line representation is given. Keto group and OH group is present. So according to the priority order, which is the principal functional group, C double bond O, so that will go as suffix, isn't it? So and that should get the lowest possible. So 1, 2, 3, 4, 5, 6. So which is the ring present here? Cyclohexane ring. So last E should be replaced by cyclohexane 1-ol. Then 3-hydroxy. The rule is same as the previous in the case of aliphatic compounds itself. The principal functional group will go as a suffix and the other functional groups will be written as prefixes only. So 3-hydroxy. Now here two cyclohexane rings are joined. So consider any one as the parent and any one, because both are same rings. So the name of the compound will be, one will go as parent and one will go as substituent. So cyclohexane. So this is the parent and this is the substituent. Substituents are parent we can identify from the name. How we can identify the parent? Or from the end of the name. The first we are writing the substituents. So here in this ring it is a cyclohexane ring with a double bond and OH. So double bond and OH, if you compare the priority, OH is having highest priority. So only if we go in the clockwise direction, double bond also will get the lowest possible number. So the parent is, it is cyclo, how many carbon ring? Hex. So cyclohex, double bond is present at the, so cyclohex, 2-ene, ene is the prefix, sorry, primary suffix, and 1-ol. So C should be capital, no other prefixes here. So the name of the compound is cyclohex 2-ene 1-ol or cyclohex 2-enol. So this is about the naming of alicyclic compounds.